Two and a Half Admins, episode 221. I'm Joe.
I'm Jim.
And I'm Allan.
And here we are again. Jim, you've recently discovered the joys of modern charging technology.
That is correct. I had not realized just how antiquated all of my charging stuff was. I thought I had been doing a good job of getting better charging equipment than what's provided out of the box and, really providing for my family and myself, because I had gotten a bunch of these, older USB-A, 4 and 5 port charging systems, with maybe 30 watts of power total for the whole thing. And I felt good about that because I hadn't really been paying attention to what was going on in the world of USB power delivery and how much juice my devices could pull down if it was offered to them. But after having some really bad experiences with unexpected, very long layovers in, airport terminals and what have you, I decided to modernize. And the first thing I did is I bought a much more capable power bank because I wanted to have a greater amount of power available for my devices. And I also bought much more powerful chargers. And I wasn't entirely sure what to expect when I did it. But what I discovered was that, rather than needing as much as 5 or 6 hours to charge my tablet with, a newer charger that could do 100-watt USB power delivery, I can spend $50 on a charger and I can recharge my entire tablet from dead flat in like 20 minutes, which is fantastic. It doesn't matter so much if you're at home, but man, it is fantastic when you're traveling and maybe you've just got 15 or 20 minutes, sitting in the good seat at like the restaurant airport or like sitting on the floor with your back to the pillar, where the AC outlet is for just long enough to charge your stuff and then move on. And if you've got a modern high-quality power bank, you can recharge the entire power bank in about 20 minutes. You can recharge an entire large device like a high-powered large-screen tablet or a flagship phone, again, in 15 or 20 minutes. You can also get much better metrics. The other thing I didn't realize I could have is my chargers and power banks now have their own displays on them, and they will not only tell me like what ports are active. They'll tell me in the case of my most powerful charger, it'll actually tell me the current and voltage on each individual port as it's charging, which is awesome because I'm not just saying, okay, I have the little icon that says it's charging, on my Android device or, random IoT gadget or whatever. I can actually look at the charger and see exactly how much power is going into that thing. And that in turn will let me know whether I've maybe technically got a connection, but it's a bad cable and I'm getting almost no charge. It makes my heart sing. And I wish I'd known to do this a long time ago.
Yeah, I had kind of similar experience. I bought these nice 4-port chargers in Japan back when all my devices were like micro USB. And so it had a little fold-out thing plugged into the wall, fit nicely into my plug adapters when I was in other countries, and gave me 4 USB-A ports, but the total output it could do was like the 2.1 amps or whatever that was common back then, pre-USB-C. And so, I mostly had it in my travel bag and it mostly plugged into the outlets nearest the head of the bed in the hotel and charged my phone overnight and so on. But I did notice that, if I was trying to plug my phone in the middle of the day, because I'm back in my room for 20, 30 minutes between the end of the day and the start of dinner and so on, I run my phone down. I would like to give it a boost charge. And my phone would be like, okay, I'll try to fast charge. And it would try for a second and then be like, nope, and then reset and try again. And nope, and then, okay, I'll slow charge. And it's like, oh, I guess I'm missing out on fast charging. And it's like, oh, I can hear it. It's pulling about as much as this device can do. And it's kind of making a faint, like coil whine type noise. I'm like, this device is at about the ragged edge of what it can do. And knowing that I could get that precious juice back into my phone quickly when I needed it in those cases, I really wanted something more. And that's really, to Jim's point, why something with a screen that tells you how many watts it's pulling can help you make sure that it's fast charging. And if it's not, unplug it and plug it back in. I mean, now it's fast charging, and know that, okay, I'm going to go have a shower and stuff before I get ready for dinner. And when I come back, my phone's going to be at 80% and not plus 5% from where I left it when it was slow charging.
The other thing that I discovered is with a modern power bank, it changed the way I use power banks a lot. I had a Sony power bank that I bought on a trip to San Francisco back in 2016 when I went to the OpenZFS Developer Summit. And it worked. I could keep a dead flat phone or tablet or whatever running while it was plugged into the power bank, but essentially I couldn't really gain on the charge that was in a dead flat phone or tablet while it was plugged into the power bank. The power bank would just keep it alive for as long as it was plugged in. You could basically wait overnight and not even really get a good solid charge of the power bank. It was just keeping your devices on life support. The new power bank with USB-C power delivery, and you can do, 100 watts on an individual line. No, it's different, man. You can literally just pop your power bank out of your bag, plug your device into it while you use it for a few minutes, top up the battery all the way up to full on your device, unplug it from the power bank, and put it back in your bag again, which is a huge, huge improvement. It also means, honestly, I use the power bank much less than I used to, because it used to be a thing of like you use the battery in your device until it's almost flat, and then you're just on life support with a power bank forever until you can get somewhere and properly recharge it. And now I'm much more likely to just use the device until I get close to somewhere where I've got power, spend 10 or 15 minutes charging them all the way back up again. And rather than just being on permanent life support, like I'm fixed, I'm back to where I started. It's a huge quality of life thing. Now, part of what you're going to need to do if you want to replicate this kind of success is you need to get away from using USB-A on the charger. I, and probably Allan, and I think most of us for a long time, had been using USB-A to USB-C cables when we charge our USB-C devices. Stop doing that, man. Get a power bank that's got mostly USB-C ports. It's fine if it's got a couple of USB on there, if you're legacy stuff. Or if it's all USB-C, that's actually fine too, because you can just get a dongle for your USB-A devices if you have any left you need to charge that way. The other thing that I bought is, part of this like wide upgrade, because I was going from USB-A devices on the charging side to USB-C all the way around, I bought a whole bunch of USB-C to USB-C cables. And the quality varies widely on those. I found a pretty neat feature. The ones that I picked, they run about $8-9 a cable, a little bit less if you buy like a big pack of them in bulk. And for your $8 or $9 per 6-foot cable, in addition to the cable itself that's capable of charging at 100 watts, it actually has an LED on one side of the cable itself that half of it lights up if you're charging, and the whole thing lights up if you're fast charging. So it's just yet another really easy indicator, like, is everything not only working, but like working all the way? And I highly recommend it.
That's a great feature, and I want it for my laptops, and I bought specifically those ones like you mentioned. But for both that and the MagSafe connectors you recommended, I need ones that don't light up for the bedroom.
So what you do, Allan, is you buy a pack of webcam blackout stickers. Those work great for covering LEDs. They're very inexpensive. They're disposable. They stick on for bloody ever. And, whenever they finally do come off, well, screw it. You bought a pack of like 30 of them for $1. So
good point.
Stick another one on.
Allan mentioned laptops, and that's what got me into this whole world of actual modern chargers, because I'd just been using a bunch of just chargers that I got with phones, and I've got an Anker one that is like a 5-port USB-A that's about 30 watts total, and I've just been getting by with that. But then when I learned that you could get 100-watt power delivery from a power bank, I could actually charge a laptop off this thing now that everything's USB-C. And then I discovered, right, well, I can get a 100-watt charger to charge that power bank. And it really is just a completely new world of speed of charging. Like I'm sure there are people listening to this going, yeah, like we've been doing this for 5+ years. Like, why have you only just discovered this?
And in response to that, I say, if you've been doing this for 5+ years, why didn't you tell us, man? I agree with Joe. The laptop thing that's another really, really nice value add. If you get a laptop that does USB-C charging, you don't have to carry a laptop charger anymore. Like, your one charger charges everything: your phones, your earbuds, your tablet, your laptop, your whatever the hell all runs off this one charger, and it's got enough power to keep them all happy. So cannot recommend highly enough. Now, the other thing I'll mention here, when you start shopping power banks, if you're looking for the biggest capacity you'll find, and say you're just browsing around on Amazon or what have you, you'll very quickly discover that almost none of them offer more than 100 watt hours, or alternately, sometimes you'll see that expressed as 20,000 milliamp hours, which converts out to the exact same thing. Now, the reason almost none of them are larger than that is because FAA regulations say that's the largest individual lithium-ion battery you can bring on board an aircraft. So when you finally do manage to find the one power bank that offers you like 150 watt hours or, 30,000 milliamp hours on Amazon or whatever site you're browsing, if you're going to do any flying, don't buy it, because if TSA figures out that that's, an oversized device, they won't let you on board the plane with it.
Okay, this episode is sponsored by 1Password. Imagine your company's security like the quad of a college campus. There are nice brick paths between the buildings. Those are company-owned devices, IT-approved apps, and managed employee identities. And then there are the paths people actually use, the shortcuts worn through the grass that are the actual straightest line from point A to B. Those are unmanaged devices, shadow IT apps, and non-employee identities like contractors. Most security tools only work on those happy brick paths, but a lot of security problems take place on the shortcuts. 1Password Extended Access Management is the first security solution that brings all these unmanaged devices, apps, and identities under your control. It ensures that every user credential is strong and protected, every device is known and healthy, and every app is visible. 1Password Extended Access Management solves the problems traditional IAM and MDM can't touch. It's security for the way we work today, and it's now generally available to companies with Okta and Microsoft Entra, and in beta for Google Workspace customers. So support the show and check it out at onepassword.com/25A. That's onepassword.com/25A. Let's do some feedback then. Justin writes, you mentioned that there is no firewall that manages IPv4 and v6 traffic together, and you need two different sets of configs. This is not correct. NF tables can do that. If you define the table as INET, you can define rules with v4 and v6 in it together. If you take a zone-based approach, it is really easy and there really isn't much duplication. If you define a chain with the policy of drop, it is pretty safe by default, in my opinion. But please don't be an idiot and drop ICMP6. Many services don't work correctly if they cannot use certain ICMPv6 codes. If you are afraid, block ICMPv6 echo requests, code 128, or read up on needed ICMP codes. Port scans aren't really a thing on v6.
I would take an objection to a couple of statements there.
Like the one that says there are no port scans on v6. I'm definitely taking exception to that one.
Yeah, but like your point about ICMP v6 there is exactly Jim's point when he said that, the firewall doesn't do both. The fact that you can't make one rule that controls all of these messages because ICMP v4 and ICMP v6 aren't really the same protocol and they have completely different code numbers. And so you can't have one rule that just does what you want. You have to have a separate set of rules for the v6 versions. While some things you can say, access to port 80 and 443, you can make one rule that will match v4 and v6 maybe. But as you try to do anything beyond very, very basic stuff in the firewall, you end up needing two rules for every intent you're trying to express because they're very different protocols, right? IPv6 isn't just IPv4 with longer IP addresses. It is a very different protocol with all these header extensions and so on that mean that the same rule can't work for both. And it's just not that simple. And then the port scan thing, I think they probably meant a little bit more the other way of like, nobody tries to scan every single IPv6 address, but that's not true either. It takes a lot longer, but definitely people out there just scanning every v6 address. And port scans, if you're targeting one IPv6 address, yeah, you can scan all the ports in the same amount of time it would take you to scan all the ports on v4. There's maybe a little bit less of people out there trying to scan every address to look for certain services, but that's more about them just targeting the lower hanging fruit. But, if you use Shodan or some of the servers, you can definitely find all the IPv6 addresses that have port 21 open and what the banner is when you connect to it.
It's probably also worth pointing out that while it might be in some ways more of a pain in the butt to port scan an IPv6 network, like the subnets are larger, so there's a larger space to cover. You're not typically going to find like one host that's actually port forwarding a whole bunch of services to, an entire farm of machines inside the subnet. That's not usually how things work with v6. Usually each machine is just going to be directly publicly accessible. That also means that like a lot of the time you can get some real bingos if you're scanning IPv6 space, because whereas in v4, you're almost always like every machine in the 21st century is almost certainly going to be behind a router with a firewall that drops everything by default. In IPv6, by default, everything is accessible, not just like the stuff that you specifically made sure to port forward through in like a router that manages your entire subnet, but every single machine in your network is directly publicly addressable, which means that you or whoever's administering your network on every single machine needed to have set up a sane firewall blocking access to everything that nobody outside the local network should have access to.
You can do that on the router. It's just you have to actively decide to do a stateful firewall. Whereas with your normal NAT on IPv4, you kind of were forced to have a stateful firewall by the fact that when you get an incoming connection to the public IP, it couldn't guess which machine to send it to on the back end. So it had to be stateful and just block it and only allow responses to things that were initiated from inside or where you had a specific port forward. Whereas V6, you can apply those same rules, but you have to choose to do it. It's not the default.
You know, we just got done pretty recently talking about how you can't trust humans to do better than the default when it comes to security. Mm-hmm. And the default on IPv4 in the 21st century is everything is behind a router with network address translation and default deny across the board, and you have to do something special to make it less secure. Whereas IPv6, by default, every machine is wide open, fully addressable to the internet, just like in the 90s. And you remember working on networks in the 90s where every single workstation had a public IP address?
Yep.
I remember those. I tiger teamed a few of those. And like you just, it's a playground for malware and black hats and whatever. Like every freaking machine has like, you know, an FTP server that it shouldn't and wares and porn or whatever on it, and, you know, barely running. And how do you fix it? You go in there and the first thing you do is you take all those public IPs away and you put the whole network behind a router with a default deny policy, and you poke holes for only the things that you should.
Yes, and that's what you should do for V6. Also, do you remember net send spam?
Yes, I do. That was never really a problem for me personally, but yeah, I definitely remember it.
Yeah, I just remember that whole concept because, yeah, everybody at dial-up would basically have a publicly reachable IP on their machine, and you would just walk the subnet and use net send to make a message pop up on every machine.
I think part of the reason that one was never a big problem for me is I was already very familiar with like the ways to abuse that kind of a tool, because before I became an official IT manager for my first, you know, real big boy job, when I was in the Navy, I worked in commands and on ships that had old school like mini computers and dumb terminals. And the AT&T 3B2 had a function called broadcast. And you could use broadcast to, it worked just like NetSend, basically. You could just pop up a message on somebody's screen. Although with the AT&T 3B2 system at broadcast, you also had the option of literally broadcasting and popping up a message on every single dumb terminal in the organization, which could mean thousands of them. And you know what? This being the early 90s, the IT departments did not lock that down. And me being who I was, the first thing I did sitting, you know, in front of one of those terminals was start, you know, looking at the help output on the command line and looking for all the commands. And I found the broadcast and I tested it. And I was like, holy crap, it's not locked down. And so I would use it to just absolutely frustrate the crap out of people. Like I'd mess with buddies, you know, I'd be like, hey, Scaleri, you fat bastard, get back to work. And he'd think that the IT department was doing it. No, I was doing it to him from sitting like 2 desks down. Matter of fact, I remember one day I did that and he was ready to go up there and just absolutely pound the crap out of the IT weenies. And I had to calm him down before he went up there and got in a fist fight. I was at least bright enough to never use the, you know, the full on broadcast function, because I was like, I can mess with my buddies and get away with it, but I'm not going to be the one who brings it to the command's attention that the broadcast all functionality wasn't locked down. I'm going to let somebody else do that.
Ben says, I was writing to ask if it seems like a feasible idea to use a ZFS dataset as a Git for data. Obviously, some extra tooling would need to be written, but generally it strikes me that ZFS already supports the concepts of commits, snapshots, forks, mount a snapshot and start working off it, and push-pull, ZFS send, for ZFS datasets, and could potentially save quite a bit of space compared to other version control systems for data I've come across. Typically blobs written to a cloud server somewhere. Generally speaking, does this seem like a reasonable concept?
I don't think I agree with calling commits basically the same thing as snapshots. But aside from that, yeah, it's quite reasonable. It actually would not be that hard to patch Git itself to directly use ZFS to save space and add a little reliability and use all of those same features that you're talking about. As far as just building something Git-like for data, yeah, whether or not you even need any extra tooling kind of is up to what your users are capable of and expect. ZFS is basically already there.
Yeah, there are some places where it might not actually be as good as Git. Partly that, when you have a delta, you're thinking, yeah, ZFS is going to only send a delta, and that's great. But the delta granularity in ZFS is going to be the record size. So even if you shrink that down to something like 4K, which will have some unpleasant side effects, that's still a whole 4K you have to modify, whereas Git with its delta compression, you'd only be like, if you only change a line, it's only going to have to send the old line and the new line kind of thing. But yes, especially for things where you're storing big binary blobs, like if you're a company that makes video games and you have a lot of textures and images and huge files that you don't want in Git, you use something like, I think it's called LFS or whatever as an add-on to Git to manage those huge files, then yeah, ZFS could be really interesting. Like Jim, I would use different bits of ZFS for your analogies. Like a commit is a bit more like a transaction, although I see your point about you want a snapshot between each commit so that you have that as a stable point. And a fork, I would consider more a ZFS clone, which is because like a fork is a version of a snapshot that you can change, and you've now got two different trees. But in general, yes, that could be quite interesting, and it would mean likely for big image files, it would be better, faster, and possibly use less bandwidth for syncing to the remote. But ZFS also is not going to be fun if you're trying to have multiple writers. But just like Git, if you just make people merge before they do it, but that's really hard to do with binary files as opposed to source code, right? You can't just rebase your patch like you do with Git if someone else has already pushed something newer to the branch than your local copy. If it's graphical files and both you and someone else have changed the files and then the other person checks theirs in, when you go to merge yours, you're going to have fun. But you would have that with a binary file, even with a regular source code control. So it could be done. I know I did look at doing something like that back when FreeBSD still used Subversion for version control, of actually checking out a revision, making a snapshot, and then walking revisions forward. So I would have snapshots at like all the different revision numbers, and I could quickly switch to a specific revision instead of having to, have the Git or SVN walk through the tree and like modify every file to be how it looked at that revision. Having access to all of those quickly, or being able to easily send the difference between a whole bunch. But I never did it because I didn't actually have much of a use case for it other than, hey, that's cool, I can build that with ZFS, which it sounds like is kind of what the same idea has occurred to you.
Okay, this episode is sponsored by Automox. Are you prepared for whatever shitstorm may hit your desk during the workday? Automox has your back. Check out the brand new Autonomous IT podcast. Listen in as various IT experts discuss the latest Patch Tuesday releases, mitigation tips, and custom automations to help with CVE remediations. Make new work friends. Listen now to the Autonomous IT podcast on Spotify, Apple, or wherever you tune into your podcasts. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And if you want to send any questions for Jim and Allan or your feedback, you can email show@2.5admins.com. Subrights. I have my own domain and host the DNS records with a popular cloud provider with DNSSEC enabled. I would like to migrate to my own authoritative server. I've only used Bind a few times and was thinking about NSD. What are some key points and gotchas for public presentation? For example, glue records, secondaries, AXVert and rate limiting, DNS amplification attacks, DNSSEC management, etc.
So the biggest thing with hosting your own authoritative servers is that you do need more than one, but you can also either use probably that same cloud provider, or I'd recommend a service like DNS Made Easy to run those secondaries for you if that's what you want. Hosting your own authoritative DNS server, I think the first thing to decide is if your primary authoritative server will be public or hidden. So one of the ways you architect DNS is you can actually have the authoritative server that defines, what these records are, actually not exposed to everyone and not listed in the whois or the glue records and so on, but instead have all secondaries there, and they pull from this other one, and that can help protect from denial of service attacks and other things, especially if you're going to have that authoritative server on smaller infrastructure and not necessarily as big as what you'd run for public stuff. So glue records, I guess to explain what that is for people that don't know, normally the way you define which servers contain the DNS information for a domain is at your registrar, you enter those DNS records, and those basically go in the whois and get put into the root TLD record. So the big database of whatis.com knows your domain, and then this list of name servers is where we look that up. But you can have this recursion problem if the name server for mercenarysysadmin.com is, ns1.mercenarysysadmin.com, you have this chicken and egg problem where you can't look up the IP address of the DNS server until you ask the DNS server whose IP address you're trying to look up. And so a glue record is basically a hint you can have the registrar contain in the database that says, and the IP address for ns1.mercenarysysadmin.com is this IP address, to let you kind of bootstrap and get that first query going. So if the authoritative name servers for your domain are inside your domain, then you have to have a glue record to kind of bootstrap the process.
I would say ultimately, you must have glue records for any name server that's going to be listed in, any domain registrar's registry. Where it's put in is generally going to be, in the domain that particular name server is a host under. So like in Allan's example, if mercenarysysadmin.com were hosted with DNS servers ns1 and ns2.mercenarysysadmin.com, then inside that zone is where the glue record would be for those two name servers.
Well, it'd be inside the registrar record, not the zone.
Inside the registrar's record, not like the zone that runs on your own local bind. But even if your name servers are somewhere else, for example, the actual name servers for mercenarysysadmin.com, I believe, are going to be ns1 and ns2.jrs-s.net. So you don't have a glue record present and I'll tell you for free, I use Namecheap as my registrar. If you log into my account in Namecheap, you're not going to see the glue for ns1 and ns2.jrs-s.net in the entry for mercenarysysadmin.com, but if you hop over to the entry for jrs-s.net, you'll see the glue there. Because ultimately, just basically, whenever you use a name server as the authoritative name server for a domain, then the registrar has to have a glue record for it. Plain and simple.
Yeah, and that's because of the recursive nature of DNS, and that's how you basically prevent the dependency loops. The next thing that Sub asked about was secondaries and AXFers. So this is only one DNS server is going to have the authoritative zone file, right? The bind configuration or the NSD file that defines, triple W's over here, the mail servers over here. These are the records. And then all the secondaries are going to connect to that primary and do a DNS command called an AXFer where we say, give me all the records for this domain. Normally, your primary name server should restrict who can do that. So you'll have basically an allow list of IP addresses that are allowed to issue this, give me all the records in your database query. And the secondaries will do this on a regular basis. The timing is controlled by the SOA or state of authority record. And it tells the secondaries how often to come and check. And if they can't check for so many days in a row, they will delete the records and stop giving out that information so that things will break and somebody will fix it. But yeah, you do want to make sure that that's limited to just the secondaries. So whether those secondaries are other servers you decide to run yourself, if you're going to use a cheap VPS provider to run a couple of different name servers, or if you contract that out to a DNS hosting company like dnsmadeeasy.com or somebody, and they'll host the secondaries, and then the IPs of those secondaries will have to be on the allow list of your bind or NSD config, so that only those people can download every DNS record in your zone.
This is important for a few reasons. One is that, for larger zones especially, asking for every single record can be a significant amount of bandwidth to which you're used to that name server having to normally supply, because it could potentially be thousands of records you get when you ask for one zone transfer. The other thing is there's a little bit of security through obscurity in there. The idea is that, for example, let's say you own joerest.com and you happen to have a private server, muckyjpegs.joerest.com, but you don't want just anybody who knows joerest.com exists to be able to ask for every single host name and subdomain associated and find your muckyjpegs server. Limiting who is allowed to do a zone transfer, that's what gives you that small security through obscurity. It makes it a lot harder for somebody to just immediately map out your entire network looking for things to attack.
So the next thing you asked about was rate limiting. If it's the authoritative name server, you effectively can't really do much rate limiting because you're the authoritative name server. You have to answer the questions about it. And in general, those questions will not be coming from individual end users. They should be coming from those end users' DNS servers, whether that's their Pi-hole or their ISP's name server or one of the big public name servers like Google or Cloudflare, et cetera. And so, yeah, in general, there's not much you can do for rate limiting there.
I would disagree about not being able to implement rate limiting. I mean, you should have a pretty good idea of what level of traffic your domain is going to hit. And, if this is like a personal blog, you can absolutely rate limit the number of requests that your server is allowed to service. Now, Google might not be able to do that because they need to be able to service every request in the world coming in all the time. But, if your blog has an audience in the thousands and your zone file has a time to live, of a day, well, you're probably not really going to be servicing that many DNS requests directly, because the way this works is not every time somebody wants to go to yourblog.com, they ask your name server how to get there. Every time somebody at ISP A wants to get to yourblog.com, they ask their ISP's DNS server, which asks your DNS server, and then caches the result before handing it to that person. So the next person at the same ISP that wants to go to yourblog.com, they don't ask your DNS server because their own DNS server still has the answer on how to get there. So in my opinion, yes, you absolutely can implement rate limiting. You just need to have a fairly good idea of what the expected volume is. One of the better ways to do that is go ahead and implement it without the rate limiting. Watch it for a couple of weeks, figure out what your levels are, and plan around that. Build yourself in a fudge factor. Maybe think about if you're planning to do something that might suddenly dramatically increase that traffic because of some big public event or whatever that generates like a huge spike of interest from people who aren't normally visiting your site. Maybe you think about relaxing it then. But implementing those reasonable rate limits, that helps keep your server from being used for a DNS amplification attack.
Although in general, the problem with rate limiting is you can, if not implemented correctly, could result in basically a second-order denial of service attack, where the bad guy can exhaust the rate limit, meaning now legitimate people can't look up your domain anymore. DNS amplification attacks are less of an issue with authoritative name servers than they are with recursive name servers. So things like the Pi-hole or Google's public DNS that are designed to answer any question that comes in are much more susceptible to DNS amplification attacks because they're going to be getting questions and relaying questions from other places, whereas an authoritative server only ever has to answer questions about the domains it controls. And so those records generally aren't ever going to be so big. Whereas the recursive server, especially if you run a Pi-hole that accidentally isn't restricted to only answering questions from your LAN, somebody could purposely ask you to look up something from a domain they control that's really big and misdirect the answer to the wrong person with the spoofed packet.
Although, again, I'm going to push back here. You can absolutely use authoritative servers for this. And one of the easier ways to do so, if you know where the server is, you probably know what domains it's authoritative for. And one of the easiest things to do is literally just dig for a text record at that domain. Odds are pretty good you're going to get some fairly beefy ones. Now, it may not be as huge as, some of the special, like, oh my God, look at this ridiculous text record I found on this one domain out there on the internet somewhere. However, you can very easily come up with a text record that's intended, like for authentication to allow Office 365 or Google to manage email for the domain or what have you.
Or even just the SPF record for the email.
Exactly. That every query, the answer will still be several times what you'd normally expect for a regular DNS query and response. And so it may not be the most perfect possible record to use for an amplification attack, but will it work? Hell yeah, it will. And these days, the way most people are using these DNS amplification attacks is they're not just like finding one server and doing the one thing there. They build a giant pool of attackable servers and they hit all of them at once. So your server is either part of that list or it isn't. And I don't think it makes sense to think that because your server isn't the perfect one to use for an attack, that nobody's going to use it.
True. That's a game where the rate limiting can come in if you can make sure that the requests that appear to be coming from a certain IP address are rate limited. It means that your responses to that IP address, even if the incoming ones are spoofed, can be limited as well.
Keep in mind, you can also do rate limiting per IP address, which, that's not necessarily going to do you a whole lot of good if you've got a massively distributed denial of service attack, where you're not just talking about distributed in terms of how many name servers are being used for the amplification, but also distributed in terms of the source of the initial packets that go to the DNS servers to be amplified to hit the actual targets. Now, if you're rate limiting per IP, it may not do everything to protect you from, one of these clouds, these botnets using you as part of their attack. However, it will knock out a lot of them, and you can implement that even directly at the firewall level. It doesn't necessarily need to be something you configure within Bind itself. And the odds that somebody needs to make 50 queries a second from a single IP address to your authoritative name server, pretty freaking low.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me at joerest.com/mastodon.
You can find me at mercenarysysadmin.com.
And I'm at Allan Jude.
We'll see you next week.